All right, so we're going to look at arrays, and in this module, we're going to both look at single-dimensional arrays, which is Chapter 7, and multi-dimensional arrays, which is Chapter 8. What I want to say in general about arrays are that they are construction that brings with us many different algorithms that we're going to have to deal with. And I'm going to try to introduce the algorithms as we work our way through things. Um, Arrays are a section of memory that store the same type of memory types. Um, and so the problem that we tend to look at is we'll look at it like this. We'll have some reference name, and then in the creation, it points to in memory a collection of memory chunks that are the same size as the type. So here in declaring an array, we have double, because these will be typed double. And then we're going to name it my list, and it's a list of things. Now it starts with the number 0 because inside of the computer, the memory has a starting address, a numerical structure that can point to a piece of memory for where all of this data is stored. And because they are all the same type, they are exactly that type away. So if I go to the starting memory address and add 0, I would end up where the memory starts for the first block. And if I would go to the starting memory address and add 1 times the size of a double, I'd go exactly where the second block starts. So the numbering system for arrays is based off of how inside of the computer it would see these different memory locations. And we're going to use the new to create this object, to create this structure. And so if we look at it in a little more detail, we have the data type and then in the reference. And so we can talk about an array here, and this is generally not preferred because it doesn't say how much memory is going to be stored for it. So generally when we create an array, we're going to prefer to have the reference, the data type, and the size. So here we have our reference is my list. It's going to be a new type of double, and there are going to be 10 elements in the array or places to put in. Now, if I want to find the first element, I would go my list and in the square brackets put in 0, and that only pulls what's in memory in the first element. If I do my list brackets 9, that only pulls what's in the 10th element. This declaration can be done in one step. We can say the data type, double in this case, the name, and then we use the new creation to create it. And this is preferred. Now, what ends up happening is these things then have a length. In fact, strings, which we started working with earlier, were a very specific type of an array. They were an array of characters. And we used a string data object to manipulate these lists. Here, we can do this generally with other types of variables. So we have some common methods that are built in. If I say the name mylist.length, I will get how many elements are in it. When an array is created, its elements are assigned default values. So you get 0 for all the numerics, you get the null 000 for all the char types, and you get false for the booleans. So they automatically pre-fill the entire list. And so you can access any one of the elements in an array. And so the lowest number is 0, and the highest number of kind of like, you can think of like an address or a postal address. So the first element is at address 0, and the last element is the length minus 1 because it starts counting at 0. And we call this the index variable. So for example, in this example here, my list, the second element is going to get the addition of the third element, the one in the address space 2, is going to get the first element, which is in the address space 0. and then the second element, which is in the address space 1. I'm really going to try to emphasize that addressing because we tend to think of the first, second, third thing. That's how we do it in language. But in computers, in arrays, we start counting at 0. Now, there are some different ways to initialize an array. I can put these 3 things into one statement. So this is double with the empty square brackets means we're creating an array. We're going to call it my list. And by using the curly brackets and commas, we put in a set of numbers, 1.9, 2.9, 3.4, and 3.5. And so this makes a list that is for long. And what that avoids is this other longer notation where you would have to assign each element individually in a line of code. In the shorthand notation, you have to declare, create all in one statement. This format will not work. So if we look back here using the shorthand notation, it all has to be in one statement that needs to create this memory, and it needs to know how large to make this memory and be ready for it here. This will not work, creating it in 2 statements there. So we're going to look at a program with arrays, and then we'll do an example with arrays processing things that go inside and outside of values. And I think the first thing we'll do is the first example program. We'll make something that will do a quick average of exam scores. But for example, if we have an array here, this integer values new int 5 creates in memory 5 spaces in memory, each the size of an integer that we can access with the address on it. I come into a for loop, and my first I value is 1. And I go from I to less than 5. And my values equal, when I go the first one, I is 1. So I get values 1. So I look for what is in the first index block as where I'm going to store memory. And then I take the value 1 plus the value that was in the block before, I minus 1. So I'm going to get 1 plus 0, and I'm going to store that into the memory location for number 1. Then we iterate, do our conditional, and we're back into our loop. 2 is less than 5. We're now going to put into memory location 2 the value of what's in memory location 1 plus the value that's in memory location, or I'm sorry, we're going to put in I, and I currently has the value 2. We're going to put in the value 2 plus what is in the memory location 1. 2 minus 1 is 1. And so 2 plus 1 is 3. And we put that into memory location 2. We iterate. I is now 3. We check I. And with I is now 3, we're going to put into memory location 3. 3 plus what's in memory block 2, because 3 minus 1 is 2, and memory block 2 has 3. So 3 plus 3 is 6. We increase the value of I. It's now 4. We check the value of I. It's less than 5. We come in, we take 4 plus what's in memory block 4 minus 1, which is 3. And that's 6. So 4 plus 6 is 10. And we store that into memory block 4. We iterate I. It's now 5. We do our check on 5. And we're done. And then in this extra line of code here, puts into the 0 place the value of 1 and 4, the first value and the last value. And so we're going to do examples of putting numbers into arrays and working with arrays. So the first thing we're going to look at is a sample program.